which is organized by the Faculty of Agricultural Technology, Universitas Gadjah Mada. First of all, I would like to introduce ourselves. My name is Manda. So, today we are going to have a awesome session with Professor Agus Harjoko, Ph.D. from Universitas Gadjah Mada, Indonesia, that will attend in this room. Associate Professor Dr. Nazmi Matnawi from University Putra, Malaysia, that will attend in this room or on-site. Mr. Iwan Winardi, Chairman of Indonesian Food and Beverage Industry Association, they also will attend with the on-site participants, and Professor Dr. Miguel Palma from University of Cadiz, Spain, they also will attend by online in Zoom meeting. They will share their knowledge and experience to expand your understanding, and also each discussion session will be led by a great moderator that know with the age expertise. Moving to the first session, the topic is about NLP and AI in smart agriculture, automating knowledge for a smarter food system by Professor Agus Harjoko, PhD from Universitas Gadjah Mada. Professor Agus is attending on-site in this room, and this session will be led by our moderator, Dr. Guntur Budi Herwanto. Let me introduce our moderator for this session by reading the moderator CV for all of you. Dr. Guntur Budi Herwanto is a researcher and lecturer at the Department of Computer Science and Electronics, Faculty of Mathematics and Natural Science, Universitas Gadjah Mada. His research focuses on privacy engineering, natural language processing, and digital health system. He has published multiple papers in international journals such as IEEE Access and has received several intellectual property rights for digital innovation, including malaria diagnostic tools and tuberculosis monitoring application. Without further ado, please welcome our moderator in this session, Dr. Guntur Budi Herwanto. The time is yours.
Thank you very much for the kind introductions. Hello everyone, good morning, and it is a pleasure to be here with you today as introduced by the MC. My name is Guntur Budi Herwanto and I will be here as a moderator for these sessions. And it is my great pleasure to be here also with our speaker, Professor Agus Harjoko, which also my colleague. We are in the same department, from Department of Computer Science and Electronics. Our building is just across the Gedung Pusat in Jalan Kaliurang if you walk over to the west. And yeah, so without further ado, I would like to introduce our speaker. So Professor Agus Harjoko is a leading expert in our Department of Computer Science and Electronics, and one of our founders as well in the department. So with over 3 decades of academic excellence, he brings a unique perspective actually to modern agriculture as the theme of today's. So what makes Professor Agus Harjoko is really interesting to talk today is he has several pioneering research in agriculture technology applications such as smart tea quality detection systems, advanced seed viability assessment, precision agriculture, and smart farming implementations. So just a little bit of background of Professor Agus Harjoko. He actually started in physics department and before moving on to computer science at the University of New Brunswick, Canada, where he earned both his master's and doctoral degree specializing in computer vision and pattern recognitions. So he already published over 100 research paper. The CV is 35 pages, so I cannot read them all. So 100 published research paper, including some numerous patents in agriculture technologies and a lot of research about agriculture as well. So please join me in welcoming Professor Agus Harjoko, who will share insight on the title is NLP, and NLP is Natural Language Processing and Artificial Intelligence in Smart Agriculture, automating knowledge for a smarter food systems. Thank you. So the floor is your, Professor Agus Harjoko. Thank you.
Thank you, Guntur, for introducing me. It is a great pleasure for me to be invited on the summer course. This is the seventh summer course in a row held by the Faculty of Agricultural Technology. Okay, please allow me to share my presentations now. Okay, so as it was introduced by the moderator, the topic given to me is NLP and AI in agriculture. But since my focus for my research focus is more on the applications of AI in agriculture, then I will just touch very briefly on the natural language processing side. And also I will discuss more on the case studies that we have here in our department and the area where we applied our AI methods for the agriculture. So the agenda for today is I will just start briefly on what is the natural language processing. It's just very brief. It's just one page. And then continue with the NLP in agriculture. But I will not go down unless there are some questions later on. And then I will be like focusing on the agricultural stages and then discuss along with that the case studies right from the seed selections up to the post-harvest processing. So the natural language processing, or it is term NLP in short, is a branch of AI focused on understanding human language. It extracts information from text or speech, depending on the input, and use it to answer the query or to answer the questions. And it is very usable in a multilingual and unstructured environments. Probably the best examples for this is like the ChatGPT and then Gemini and then DeepSeek and so on. And some, in principle, the NLP start with taking the input from human voice or human talks. Probably I will try to use the pointer. Some human talks or text, and then the machine will capture the audio or the text. But if the input is text, then the position is directly on this position, and then the machine will process the text data. There are a number of stages in text processings, like the cleaning, normalizations, and then taking features, either using handcrafted features or the convolutional features and the like. And then the result is converted into the audio if the answer has to be given in audio. However, if the answer is to be given in a text, then the process is given directly in a text. So that is briefly how the natural language processing works. And now we are continuing with the NLP in agriculture. So it can be used to read agricultural bulletins and then summarizing this report. Like if we don't have enough time, for example, we could use samples that I have mentioned before, like ChatGPT or Gemini, or the DeepSeek to summarize the paper for us. Now, it can also understand farmer queries, either given in a voice form or it is in a text form, and also monitoring social media feedback, answering farmer questions in local language. Just like in this example, for example, I can ask 3 of the examples before, either it is Gemini, ChatGPT, DeepSeek, in Bahasa Indonesia. And we could get the answer in Bahasa Indonesia or in English or in your language if you are not speaking Indonesians. So in the context of the agriculture, it can give us the planting advice and weather, and also the pest control done on other regions that we might be interested to apply that to our local agriculture. So there is a very good example from the United Nations, FAO's. It is called the Plan Village Nuru. You can easily Google this one, or if you want to get it very fast result, then just ask either one of like ChatGPT to give you the summary of what is Plan Village Nuru able to do. So it basically process the natural language and also apply computer visions to recognize diseases, for example, in some plants, and asking for how to overcome the kind of diseases or to treat the diseases. As I said before, I will not go through that one. But I will go directly to the agricultural stages, and we are passing along with these stages, discussing some applications or research that we have done and then applied in our local area here. So the stage start from land preparations, like clearing, plowing, piling, and leveling. And of course, it could be done manually, like in the picture on the top right corner. But it could also be done using a machine or automated machine. And then from land preparations, we go to planting stage, where we have to have a good seed. So we did a research also on seed selections process or seed viability detections, and it is done with in collaborations with the researchers on this faculty also, and the Faculty of Agricultural Technology, and also the Faculty of Agriculture. And in planting, we might want to zone and also put some spacing. Again, this could be done manually, which takes a long time, but it could also be done using a machine. So then after we have planted the seed, we go to the next step, which is the crop management. It includes the irrigations, how we manage the watering of the plants. Of course, the oldest one is the manual irrigations, but we do also the IoT controlled irrigations, and then we do also the fertilization. And so we do also research on getting the fertilizer. And then weed control that we haven't done yet, pest and disease management. We are planning to do it this and next year, so we cannot report it right now. So then we go on growth monitoring, and then the harvesting. And the one most important things in harvesting is to determine the correct timing for the harvesting. I will give you an example, one example for this later on. And then some post harvesting, which handles like cleaning, sorting, and grading, even storage, processing, and packaging. So we will go through the both words or terms that we will give some example on that one. And then the last one is the marketing distribution. But another way to look at the agricultural stages is we could divide the processes into three stages. One is called the pre-harvesting, and then the harvesting, and then post-harvesting. And the pre-harvesting, it starts, actually there is one thing that's missing here with the crop recommendations. So what crop are good to be planted on a certain area? I think Thailand is very advanced on this case, and they have soil maps for the whole country, so that the government officer could give an advice to the farmer what kind of crops they should plant for a certain region. Okay, and then based on the crop selected, then we have to choose the best seed to get the best result. And then when we deciding the crop to be planted, also we should consider the environment, like the soil, the texture of the soil, and so on. And then pesticide controls, detection of weeds and identification of weeds, and how to manage them are among the processes in the pre-harvesting. Also including the disease detections and also the irrigations. Now, the second stage on the second view is the harvesting. For the fruits, usually we indicate with the skin color, the firmness, the size, the age, maturity, and also detection and classification of fruits or the before the processing. Now, the third stage is the post-harvesting, which include the shelf life, the temperature, and then the quality, and then also the fruit grading, and also the humidity for storing the agricultural products. Okay. With the smart farming, we integrate many things, including the automated irrigations, and then the drones which are used for the monitoring. Either it is for detecting the diseases or determine the timing for the proper harvesting, and then temperature and humidity sensors for the lands, and in post-processing, it is used also for the storage. And then also the wireless connectivity. Of course, this one is required because we have a lot of IoT planted on the agricultural area. and then report that conditions to the server for further processing. Okay, so now we will look at some examples. Okay, we start with the pre-harvesting stage, and we start with the first one, which is the crop recommendations. So there are a number of parameters that we should consider when we would like to determine what kind of crops we would like to plant on our lands. There are four parameters, main parameters. One is the environmental or agronomics, and then second is the economics, and third, farmer specific and social. And then the fourth one is the regulatory or policy factors. Now, from the agronomic point of view, we have a climate, how much like the rainfall we have, and then soil conditions, the texture, and then the fertility, so that we have also to understand the fertility or measure the fertility of the land, and land characteristic, pest and disease pressure, and also previous crop history. So normally we are not planting the same crops from time to time, but we plant other kind of crop for certain periods of time. Now, later I will give you the example for the onion case, where the onion case is planned only for a certain month. It is on July, which is this month, and it will be like harvested at the end of August or early September. We have a case studies on that one. It is about 200 hectares. And then also the economic factors like the market demands, and then also the input cost, the seed cost, and then the profitability, also the infrastructures that we have for that. And then from the farmer-specific factors, we could see something like available resources, then risk tolerance. Like tobacco, for example, is very risky right now since the weather is unpredictable. Rains come from time to time, and tobacco is not tolerant to rain. And then regulatory or policy factors, and some government policies give subsidy for a certain crops, while others not. So if we want to have the subsidy, then we have to select a certain crops that will be subsidized by the government. Okay, we start from the first one. This is about the seed selections. This is, by the way, still in progress right now. The machine itself is across the street from here. The lead researcher is from this faculty. I'm helping in the computer vision area. So the condition of the seed might be able to be observed from outside, and we could determine the quality. But it is not always the case. It's sometimes we need to see the inside of the seed. Now the picture on the left here shows us what is inside this seed. Okay. Now with the golden standard or the manual process right now, it takes approximately 2 weeks to grow the seed until we could determine whether this one and the seed is good or not, viable or not. At some time the seed grows, but it does not growing perfectly. Now, if we could see what is inside, then we could determine the quality in very short time, probably in a matter of seconds rather than weeks or days. The examples on the right here shows us the low quality seeds where there are some lack of food storage on this picture, and also some cracks on this picture. But most probably the embryo is damaged on this one, and there is still embryo here, but it's very lack of seed to grow for initial growth. Now, when we approach this seed selection process by using a machine, the picture is not ideal like the one on the left, but the one something like the one on the right. So this is a challenge for us to be able to predict the seed, whether it is viable or not, based on the picture, which is not perfect. So this comes the artificial intelligence to help us. We collect thousands of data for training and now for predicting. The initial results up to now is approximately 90% accurate. It's still 10% the company, well, it is accepting, the company is accepting, but requesting for higher if it is possible and also faster. So the main problem with the X-ray inspection is that it requires approximately 2 seconds for the X-ray itself, but the processing is in milliseconds. So the bottleneck is on the X-ray. So we are on the second year now, try to capture more seeds so that in overall the seed per second, and the number of seed per second processed will be higher. Okay, from the seed selection, we will go now to different case, unfortunately, or fortunately, because we just started the seed processing. Now, just to give you the idea, the onion area for the farming is approximately 200 hectares. It's not a huge area, but it's good size for research. So that when you try to cover by food or motorcycle, it doesn't take a long time. So there are 3 problems with this one, and we will see one by one, except the last one. First is the irrigation. You can see here that the water level is below the farmland. So the water from this river has to be pumped up to the irrigation channel up here. And of course, we could not pump every time, every day, or start pumping and then waiting for 2 hours or so for the water to reach our farmland. So we create an IoT to control pump, which then waters the agricultural farmland. And so that when the farmer come to the area, they don't have to wait for the water anymore. Okay, and then another thing that we do is also the fertilization. So normally a farmer will just put fertilizers from the store and then throw the fertilizers without considering what is a certain nutrients needed for the onion. So we try to map the nutrient for the area and then come up with the suggestion whether they have to put the N fertilizer or phosphor or kalium. So it doesn't have to be all nitrogen, phosphor, and kalium. Okay, so this is the water up after we pump up the water from the river to the irrigation channel. And this is the onion field. And from this is approximately in the center of the farmland, and the area up to that point is approximately 200 hectares. So to overcome the irrigation problem, we install pump. Fortunately, the government provided the pumps, a huge pumps. There are 3 pumps there. And so what left for us is to design the IoT to control the pump. We installed the water level sensing so that when the water level is sufficient, then the pump will be stopped. Otherwise, the pump will be turned on. Now, the pump could also be turned on or off manually by using the smartphone. So it doesn't have to go to the control room for the pump. So this is the pump area. It's not clear. It is a small thing. And this is the control that we created for this farmland. And this is the condition for the water. Now, another thing that we do for the next step after seed and watering is the fertilizers recommendations. As I said before, farmers normally just buy fertilizers and then pour the fertilizer onto the land, hoping they get a good result. But we've seen that there are some waste in fertilizer, so we try to map the nutrients conditions. And the one on the left here, this is in Bahasa Indonesia, but this is the maps of the onion farming area, and different colors mean different nutrition contents. So based on this nutrition contents, then we could suggest to the farmer on how or what kind of fertilizer they have to buy, and then spread over to the area. Okay. And this is the drone that we use for the mapping, and these are our teams. Mostly are the undergraduate students, but we also have graduate students involved on this project. Now, the mapping that we get from the drone is confirmed with the ground measurements device. So this is, we also developed the device, this white things one. So we put the device onto the land, and then we get the measures. It is displayed on this device, but it also transferred to the server. So the data could then be processed to get the distribution for the whole farm area. Okay, now we move to the still the fertilizer recommendations, but in addition to purchasing the fertilizer available on the store, we do also a research to get something what we call the SROP. It is a slow release organic parametric. It is a soil management, and it is created from chicken slaughterhouse waste. So we process the waste using a certain method, and the method is, by the way, developed by our college and the Department of Chemistry. But we to design the reactor, and we designed the reactor to be mobile, so that we could bring the reactor from one slaughterhouse to the other slaughterhouse, stop there and process there for approximately 5 hours. And then after 5 hours, we wait for another 3 hours for the product to be cooler, and then we could transport the product wherever we want to use the product for. So this is by the way the product looks like, or the reactors looks like, and this is the slaughterhouse. Okay, from this research, we also proved that the product that we have improves better yields for the onion case. Now, this is another research also, but this is for chili, and detecting from leaf to determine whether the class like the deficiency. And the first one, for example, is the calcium deficiency. This one is also calcium deficiency, and then this one is multi. So a number of deficiencies happens here or occurs here. And then this leaf is healthy, and so on. So based on this observation, also we could like recommend what kind of fertilizers to be used for that particular plant or planting area. Okay, the next step is weed detection or identifications, but like I said, we haven't done research on this one yet. So for now, for our onion farm, like this is the weed, the small one here, is treated manually. It's by hand, picking them up. So waiting for some time to research on that one. Okay, now we move on now to the harvesting stage. Now there are some parameters that normally used for determining the time and the proper time for harvesting. These parameters include the skin colors, like mango skin colors, but be careful that the skin colors is not the only parameters. And then also the firmness, and then also size, whether the fruit is small or large, and then also the age maturity, which sometimes we could see from the skin color combinations with the texture and so on. And then in the harvesting state, we might be required to do some detection or classifications of the fruits to separate from, like say, based on the size or based on the maturity of the fruit and so on. Now, I will give you one example of the pineapple case. The production rate for this pineapple farm is approximately 20 tons per day. So this is a large area. It's not only 200 hectares like the onion case. Now, the problem related to the harvesting time is to determine the right time to spray what they call the ripening stimulants. Why they want to spray the ripening stimulants? Because when they come to the harvesting, their machine is like this one. And this is the almost a size of an airplane. So it's more than 12 meters in spans. And it is still semi-manual. Now, there are persons from this, I think this N, person here that will takes the pineapples and then put it onto the conveyor. The conveyor will bring the pineapple to the center area here and then moved on to different pineapple. And finally, the pineapples comes or put on this truck. Now, the other side of the wings, also the same thing. And also, so when the harvesting times comes, they will do the harvesting at once. Okay. Now, and that's the reason why they want to be able to harvest at one time. So, in one day, they expect to have like 20 tons or so, sometimes a little bit over. Now, however, when we do not spray the ripening stimulants at the right time, the production may drop up to 20%. So 20% of 20 tons is approximately 4 tons. So a loss of 4 tons is something very significant for this farmlands. So how do we determine the right time to spray? In principle, we fly a drone and see the coverage of each pineapple trees, and from the spread or the size, we could determine the time. Now, of course, we need a lot of training data, but they do have training data, and they have drones flying from time to time. So, like what we have to do is to use that training data to determine the right time. Okay, so this is one crucial thing for determining the harvesting time. Now, another thing, this one is from, I took from a paper in Malaysia, I think in the Perlis area in Malaysia, where they have a mango farmland, or the way to determine the condition is by classifying the chlorophyll content. So they also use the drone to flown over the farmland and then determine the time for the harvest by analyzing the chlorophyll contents. And they use also CNN family from the aerial images. Now, we go now to the last part of the of this discussion, which is the post-harvesting stage. So we have discussed the pre-harvesting, the harvesting stage, and now the post-harvesting stage. Now, there are also parameters that affect the post-harvesting stage, which is the shelf life, temperature, humidity, and then also the quality and fruit grading. I bring you to the first is the mango case from the same paper that I showed you before from this one, and this is the mango. From the mango, then they do the segmentations and get the mango and evaluate the mango. Now, in this case, this is just a shape and weight grading. So basically, it is a size. But just like in the egg grading, the unit is weight. So somehow we have to convert from the camera position or picture into weight by some calibrations. but it is not something difficult, but we just have to do it. Okay, now the second case is the tobacco leaf processing. Since we are discussing only on the post-harvest, so it starts by picking the tobacco leaf from the farmland, and then the first step is the drying process. Now, manually, this tobacco leaf will be put outdoor, and then dried by sunlight. It is cheap. However, it takes a lot of space for drying process. And also there are problems in the when rains comes. So the next move is to dry the tobacco, but in a room. So if you could imagine, for example, this is the room to be used for drying process. If we lay down the tobacco leaf, this position, just like this one, then it will not, or the capacities will be very low. It will not able to dry a lot of tobacco leaves. So what we do is then, we try to hang the tobacco leaf in this position, and then so it takes around the area and also in a certain height. So by that position, then we could dry up the tobacco leaf and the huge amount in the small room. But of course, instead of using the sunlight, we have to create an IoT device to control the temperature and humidity. Now, wrong temperature setting or humidity control will destroy the tobacco leaf. So we have to be careful with this one. But fortunately, they have knowledge on that one, and then with some time we learn, then we could create the IoT control that is working. Now, after the tobacco is dried up, then it comes to the next process where we do the grating. There are two stages in the grating process. One is just to determine whether the tobacco leaf is defective or not, good quality or not. Basically, it's just two classes. This is good and this is not. This is the first prototype that we have, and it is still in our lab. But the second prototype is installed on the company which process these tobacco leaves, and also using the conveyor rather than sliding manually. So this is just for the research purpose. And then the conditions of the tobacco leaf is shown on this monitor. So the first one is just saying this is good or not good. And then for the qualified tobacco leaf, we then classified them onto 24 classes. So to my eyes, this tobacco leaves is just brown, right? Probably to most of you also the same thing. But according to the expert and also to the standard, Indonesian standard, there are 24 classes, which consists of 3 basic classes, the bluish class, reddish class, and yellowish class. All are brown, but yellowish brown class, reddish brown, and bluish brown. So this is where the AI plays the role, where we want to classify these leaves into 24 classes. So basically, and in the research process, we put the tobacco leaf here and then slide this one inside. So there is a small caps here for the tobacco leaf to get into. And then we have a camera there, which observe the tobacco leaf, segment the tobacco leaf, and then finally determine the class for the tobacco leaf. Now, again, for the second prototype, it is consists of conveyors, but it was still like fitted by human being, and then the class is also separated by human being. And the next step is, of course, to replace this human being by a robot, which will take the tobacco or put tobacco onto the conveyors and then takes the tobacco outside after classifications and put it on the correct bins. Okay, now this is the third case for post-harvesting process. This is a tea plantations area. This area or this tea plantations area belongs to Gadjah Mada University. And the production rate is approximately 15 tons of wet tea leaves. Then the tea leaves is processed. This is when it comes and it's weighted, and this is the weighting station. And then the leaf is then processed, dried up, and then chopped onto the small pieces like this one. But our research is on determining the grade of the tea based on this color like this one. So manually, what is done by the tea tester is they have a procedures to have a certain amount of tea put in a pot, a pot. And then this pot is boiled at boiling time. And then the tea which is already on this pot is poured with water and then wait for 10 minutes. After that, then they will smell the tea and also analyze the color. Okay. So that's the manual process for that one. And we do that for the machine process. So basically what we do right now is we are using the eNose to replace for the our nose and use the camera to replace our eyes, because our nose and our eyes may get tired and the result is not consistent from time to time. And so we try to replace that one. But this is still in the process right now. So and there is a publication related to this one using the eNose, but there is no publication yet when using the camera for determining the tea quality. Okay, now I would end this talk. By showing the challenges in IoT-based smart farming. So the first one is I'm taking from a paper. The first case study is a cyber attack on smart irrigation system in California. And it is very similar to the irrigation system that we have in our onion case, right? That the water pump could be controlled by a system, whether manually using the handphone or through a sensor. Now, what was happening in California is that a cyber attack has disrupted the automated watering schedules. And so some plants could not get enough water, so it's becoming stress, and it was estimated the loss was about $1.2 million. Now, in our case, hopefully there is no cyber attack for that one. We have not equipped with proper encryption for the site. Just hoping there is no cyber attacks for our side. So this from these cyber attacks, we learned that we have to have strong cybersecurity measures, and such as the end-to-end encryptions, multi-factor authentications, intrusion detection, and so on. And just imagine that this may happen to any other the IoT device. And the second case study is the connectivity failures, and it happened in India. So I think the state or the province is the Maharashtra. They have a connectivity issues due to poor network coverage. So some of the area are not covered by network, or the network is not stable. So when, like for example, the command to turn on the pump will not work when there is no signal at that time. Probably it's just 1 second or so, but the command happens on the time. So we might need, I think, a mechanism to check or to get the feedback of our command to our water pump. Now the solutions there was to provide a low power wide area network and edge computing solutions. Now the area that we do for the onion farmland is not that wide compared to this case in India. So basically, if we put an access point in the center and use LoRa, for example, then it would be sufficient. But to control the water pump, we need a relay because the position is a little bit far. And then the third case study is the interoperability issues in a large-scale IoT farm in Australia. So this is also from paper. It's not our experience that we buy off-the-shelf IoT device and then try to integrate them. But the problem is on the communication standard of these IoT devices that they bought from the store or off-the-shelf IoT devices. So the solution for this one is to adopt the standardized IoT framework and also the middleware solutions that will enable communications from one IoT device to the other IoT device, which is produced by a different company. Okay, that's all. Thank you for listening. Hopefully this is useful for you. And I will return the time to the moderator.
Thank you very much, Professor Agus Harjoko, for the comprehensive presentations about each steps of the agriculture and how mostly computer visions and a little bit of NLP can assist with that. So now we starts for the questions and discussion sessions. So feel free if you have a question, you can raise your hand or directly speak to the mic near you. Do we have one in the room probably? first? Or I'm not sure how can I see the Zoom. So probably if someone in the Zoom have answers, they have questions, sorry. Okay, so probably I will start first, yeah. So just to uh, come up with the first question first. So I think it's very interesting, Prof. Agus, with all of the implementations of computer vision, NLP, and several other technology for the agricultures. So what I want to ask is, so you have worked on this for quite a long time, and I think computer hardware is evolving always, like every year. The computer hardware, like our smartphone, getting more and more powerful with the chip, the Snapdragon chips, and all of the NPU chips. So do you have any experience with working only with smartphone in relation to the agriculture computer visions? Yeah.
Okay, thank you for the questions. Yes, simple answer is yes, we have the experience with that. In fact, the first time we developed the tobacco classification is on a smartphone. And just to get the feeling of how fast is this smartphone, can it be used for other things. And then a friend of mine also developed the disease identification for mango leaves, also on the phone. But in our case, the final implementation is not on the phone because we implemented on a company. So we use standalone PC instead. And that is free from cyber attacks because it is standalone. But for IoT device that we use in onion farmland, we have an application also on the phone that I don't have in my phone, but in one of our team. So we could turn on and off also from this campus for the water pump there. Okay. But also the farmer has also just one farmer. Not all farmers are given access to that because we afraid that they will just play around with the control and it may end up with damaging the water pump. So a handphone is very powerful for this one. It's very convenient also because we can bring everything. In fact, we could see the nutrient maps on the phone also. So, and with that map, then we could like look at pinpoint which one, which area is good for is good nutrition, which one lacks for and component, nitrogen component, and which one select for the calcium component, and so on. Now, along the growth of the plants, normally they will need the nitrogen first and then calcium later when it start like having the fruits. Okay. Also, the what is it? Village, plant village, Nuru, is also implemented on a handphone. It has the computer vision capabilities to like detect diseases based on leaf also. Okay, I think that's.
Thank you very much for the yes. Please, you can go on with your questions.
Hello. Hello, I'm Gia from University of the Philippines. And I just want to say that I think it's very great that we can use
language-based models of AI for farmers, so that all the knowledge that we have, it can trickle down to them a bit faster. But as agriculturists, I want to ask, how do we adapt to the changing demand in expertise, especially in the advent of AI-led agriculture consultancy? So basically, with AI, there will be a time where, like field workers, extension workers, there will be less demand. So how do we adapt to this as young agriculturists that are still gonna be starting in the field?
Okay, thank you for the questions, and welcome to Indonesia from Philippines. I just visited once Philippines, and okay, basically the questions, if I'm not mistaken, is how do we adapt as an agriculturalist to the AI world, which is something is coming now, and we have to adapt this one. Well, you can adapt at many levels that you would like to. One is probably the simplest one is that you are working in a group which consists of agricultural expert, which is yourself in this case, but also student or people from computer science or information technology area. So then you can work jointly. Just like what we do here, we never do a research on our own for the area of the agriculture. We always do research together with expert from the agricultural technology, the Faculty of Agricultural Technology, which is here, and also the Faculty of Agriculture, which is the neighbor of this one, and sometimes with the Faculty of Forestry, because they have knowledge. And basically what we do is just we compute. Just computing. So, and that's probably the first level. Okay. And then the second thing is that, of course, you could start learning programming. And now there is a claiming, I think, from Gemini that Gemini is the best applications or model for programming. I haven't proven it yet, but the claim, I just read the claim this morning, by the way. What I know is that ChatGPT is used for programming also. So we throw the concept and get the program from ChatGPT. But now Gemini claims this is the best. He is or it is a better one or the best one. But I haven't proven it yet. So I believe that in the coming years, programming is not done by writing code line by line, but giving a concept. Of course, it has to be detailed concept, which could be understood by an AI model, and that model will generate the programs. And we have to prove whether the program is correct or not. So do not trust the program to the tool itself. Tool is a tool, but we are responsible for our doing, for our research. So we have still to evaluate that one. Okay, I think those are two major things, but how far you want to learn programming really depends on your position when you are working. If you have your own company, you will ask somebody else probably. But if you are working in a company and you are required to be able to program AI, then you will need to learn AI more. Hopefully, I answer your questions.
Thank you, sir.
Thank you so much for the questions. We have one more question from the Zoom. I will read the questions to you, Professor. So, good morning, Mr. Agus. I have interest in the water pump irrigation management for onions. Since the water pump switch needs internet signal, it can face networks problem like in your presentation. Can we make it into Bluetooth like system to make the switch have less problem in signaling? Thank you.
Okay, thank you very much for the questions. The way I see it right now, if we are using the internet only, there's problem. You are correct, I think. But there are also solutions like the one in India. They have a network their own, and we are using LoRa also. Now, one thing to overcome the problem of command that does not reach the destination is always to have a feedback on site. So we have to install a sensor whether the water pump is on or off, and that will confirm our command. If we want to turn the pump on and the conditions there return to us is that the condition is off, then it means that our command is not accepted by the device. Now, on the other hand, if we want to turn off the water pump and the water pump is still on, it means that our command is also not accepted by the device. Now, in our case, we also have a sensor which is installed along the irrigation channels. I think we have 3 sensors along the irrigation channels for the 200 hectares. So one is in the middle, the other one is the early section, and the other end, there is also a sensor. So this will help us confirm also the water level. And if the command is given by the IoT asking for turning, then in principle, the IoT will ask for turning on the water pump until the water level reach a certain height. Otherwise, it will require for turning off the water pump. Now, what we concern is, however, if someone plays something or hack our system, is asking for turning on the water pump again and again continuously, while we would like to have it off, then there is also a possibility that our onion will also get over watering, and that will cause a stress to the onion plants. Okay, hopefully I answered your questions.
Thank you, Prof. Agus, and thank you, Fania Juliana, for asking the questions. So, do we have another question?
There is a question there, back there.
Okay, thank you for the opportunity, sir. Actually, I'm curious about our NLP and AI-based smart farming system only effective at scale or in a big scale, or it can be possible in like home scale maybe? And are these concrete strategies to ensure the system are not only technically efficient but also in socially and economically inclusive? And by the way, I'm Alisa from Universitas Brawijaya, Indonesia. Thank you.
Okay, thank you, Mbak Anissa. Welcome to Jogja. 8 hours by train, I think. Again, the one that I show here, and it is the research is done in a home. It is, by the way, is one of our house. A few years back, we have chili plantations. We have a camera installed, IoT also installed, and watering system, and also the nutrition control system all at once. This is done by a PhD student in our department, computer science and electronics, but also one of the supervisors is also from this faculty, the Faculty of Agricultural Technology. So he is the one who has the expertise on this, what it is, fertilization and calcium deficiency and so on. But the AI programming is done by our students, who is now also a teacher in, I believe, in President University in West Java. Okay, so yes, it can be implemented on a home scale, especially if you have like hydroponic or other types of farming in your your garden or your houses. And also there are some security issues probably on this one. I'm not sure, but at that time there was no problem. In this case, we do this for research. It's not for hobby. So we stop after the research completed. But you can continue, of course. And I believe, and I know that there are some people who implement the same thing or similar things to watermelon farming, which is also on a garden, and they have a good result also. And if you want to do research, I think the government will be happy to help you financially. It's just that you have to have a supervisor. Okay, hopefully I answered your questions.
Hi, sir. My name is Sơn from Vietnam. Because you are working in some IoT system now, so I want to ask you about what's the problems can you see when you make the farmer accept our new technology, and your solution to make them accept that. Yeah.
Okay, okay.
Yeah. What is the most difficult problem for you to make a farmer accept our new technology? Yeah. How to change their old habit? Yeah.
Okay, thank you, thank you. Okay, I will go back to the onion case. Okay, there are a group of farmers here involved, and the area covered by this one is in about 200 hectares. Now, of course, it is something that we have to introduce, and not all farmers are happy at the beginning. So what we do is we approach the social leaders on that area, and it takes probably half a year to get them accept the technology. But then after that, they are happy if we want to, let's say, rent some of their land for research. Now, so the first thing that we implement for them is something that will help them directly. which is the irrigations. So before this irrigation is controlled by IoT, what they did is like they get up early, 2 o'clock in the morning, go to the farmland, and they found out that there are no water on the irrigation channel. So what they have to do is then they have to look for sort of water, which we know it is below the level of the land itself. And so, and basically there is no way to get water from that one, but there is another very small creek that will be able to supply the water. So, but they are used, this creek is used by many farmers. So, and then they will get the time for them to flow the water onto their area, but then they have to wait for hours. So even though they go to the farmland about 2 o'clock in the morning, but they get water approximately 5 or 6 o'clock in the morning. So it is something of wasting time, right? So that what we promise us to help them. Now by that, then they finally happy that they will get help, and so then we go to the farmland, do some initial survey, what is the water channel there or irrigation channel there, and see where we could put the sensors, and then develop the IoT to control the water pump. Now, along with that, we are very lucky that the province of Yogyakarta helped them with 3 water pumps. It is a huge water pumps. So then after the water pump is implemented, then we control that water pump. And now when the farmer goes to the farming land, they always find waters there ready if they want to flow them to their field. So that's this. So I think the key is that if we could ensure or convince them that we will help them, then they will be happy to accept. But if like we require something that they have to do and the benefit is not clear, then of course they will probably reject the approach. I think that's the key point. So just convince that what we are doing will help them. Okay. Thank you for coming to Indonesia. I think last May, end of May, I was in Vietnam for just 2 days. What is a good city is, I think Ho Chi Minh is developing very well now. Yeah.
Thank you for the questions. We have one more question probably from the Zoom. The question is from Siti Juwaila. In the automating knowledge for a smarter food system, if farmers try to utilize this automating knowledge and then experience crop failure after implementing the system, further research might be unnecessary to achieve a successful harvest. However, if continuous updates are required, it seems that it would increase expenses and affect the economy. What should be done when such a situation occurs in my area? I would appreciate your advice, sir.
Okay. Thank you for the questions. This is probably something that we have the privilege on. Now, we are, as the lecturer of university, we are fully backed up by our government for financial help for many things. So in this onion case, we do not take any money from the farmer. We get money fully from our government to develop the IoT device, to test, to survey the situations. However, if a failure happens, like let's say we have a controlled irrigation system, and then the onion harvest happens to be like fail because of the pest, for example, and then it is not the mistake of the irrigation system. Yes, they do have a problem with caterpillar pests, weeds, and so on, and it is our next step. But again, the funding are going to be obtained from the government through a research proposal and also the community services proposal. Different thing might happen if, for example, the funding is coming from the farmer, then they will demand that the result has to be very good, for example. But for that things, we do that scheme only with company. So, for example, in the case with tobacco, in the case with pineapple, they are companies. They have the money. Also for the seed selections, they have the money. Their market is all over the Indonesia. So it's okay for this thing, but not the farmer directly. So I think to recap my answer to you is that if we do need further research because of some failure happens to our product or things, in this case, we will resort the fund not from the farmer, but from government or other industry that might help them, not directly from the farmer. Okay, thank you.
Thank you very much, Prof. Agus, for the answers. I think we can have one more questions if you have. Yes, please.
Good morning, sir. I am Alfatra from Philippines, Western Mindanao State University. My question is, since we are solely focusing on crop science, I would like to ask, what do you think are the potential IoT application in animal science or livestock?
Okay, thank you for the questions. And again, welcome to Gadjah from Philippines. Okay, there are also some research, and we do also research for the livestock, especially for the chicken livestock. So in Indonesia, normally our what is the room for the chicken livestock is approximately 12 by 48 meters a block per block. And then we might have number of blocks, but for each block normally is just about 12 meters by 48 meters. And what we can do there is that the health of the chicken is affected by temperature and humidity. So in principle, what we do is to control the humidity and also the temperature. And that's happened also to like when we try to breed from egg to a chick. But the control is different from egg to breed to chick. It's a small room, but this one is a larger room, and normally it is open. So we use a blower to distribute the temperature and humidity to try to get as even as possible. So for that case, then we need a number of temperature sensors and also humidity sensors. Now, since chicken is normally approximately only from approximately 20 to 30 centimeters from the ground, it doesn't mean ground is soil. It could be on second level, it is floor like this one. So our main concern is on the heat for approximately 30 centimeters from the ground. Now, what happened to the temperature up there and the ceiling, for example, does not really concern us. So by adjusting the circulations, the temperature, humidity, where we have multi-sensors there, then hopefully the chicken will be healthy. Now, that one is still in progress, so we don't have the result yet. But I believe that if we get a correct knowledge from the expert, then we could implement it, then we believe that the result will be good. So the key is always that we have to work together with the expert. And most of you are the expert on the probably livestock, crops, and so on. And so we have to always work with you or your college. Okay, thanks.
Thank you, thank you. And I think that's the last question. Can we give a round of applause to our speakers? Thank you. Thank you so much, Prof. Agus, for the very, very interesting presentation. What I can probably just shortly summarize is the advance of computer. I think nowadays is comprising from the vision, so the computer can see, computer can understand language with NLP, and computer also can smell. So you mentioned about the last part with electronic nose. I think that's very, very interesting as well. So there are a lot of sensors that computers can help with the agricultures nowadays. So yes, thank you again for the very, very interesting presentation. And thank you also for all the participants for the attention and also for the fruitful discussion that we have based on your questions and our discussion. So I think that's all. I would conclude this session. Thanks again, and we hope to see you again in another chance. So thank you, thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you so much to Professor Agus Harjoko for being an insightful lecturer about NLP and AI in smart agriculture, automating knowledge for a smarter food system. We would like to give the appreciation certificate that will be given symbolized by our moderator. And also, we would like to thank Dr. Guntur Budi Herwanto, who led the discussion before, and the certificate of appreciation will be given by the chairman, by the vice chairman of the 7th summer course program, Dr. Rifki Mautoko. With the session of appreciation certificate already implemented, then the first material of the summer course has ended. For operators, you may stop the recording for the first session.